Continuing the section 3.4 notes, we conclude with example 4. We're going to solve a fourth degree polynomial equation, again making use of the graph. Remember, you can produce these graphs yourself using a graphing calculator or using Desmos, to which there's a link through MyMathLab. Easy to use, and you will definitely find looking at the graph to be helpful in determining the solutions of an equation or the zeros, which are basically synonymous. We need to begin with a list of the possible rational zeros. So we'll look at our constant term of -5. Those are the divisors of that are the p's. So that would be plus or minus 1, plus or minus 5. And then our q's come from the leading coefficient. Plus, we're dealing with 9. That would be, you'd have plus or minus 1, plus or minus 3, plus or minus 9. And then from those, form the p over q's. So take the p's and divide by the q's. So you'd have plus or minus 1, 5, and then let's see, 1/3 and 5/3. And then 1/9 and 5/9. Okay, so those are the candidates for rational zeros. Plus or minus 1, 5, 1/3, 5/3, 1/9, 5/9. Let's see if we can use the graph to find a number in that list that looks like it's an x-intercept. So taking a glance here, 1 and 5, I don't see anything there. 1/3. 1/3 looks like a good possibility. That would be right here. I noticed how the graph just touches there at 1/3, by the way. There's some significance to that. Let's see if there's anything else. 5/3 is 1 and 2/3. That doesn't look like that'll work. 1/9, that would be, that's close to the one I just indicated, but that appears to be 1/3, not 1/9. 5/9 is a little bit bigger than 1/2. That doesn't look to be a possibility either. And of course you could deal with the negatives as well, but none of the negative possibilities appear to actually be x-intercepts. So it would appear that there's really only one number worth checking, and that would be 1/3. So let's give that a try with a synthetic division. Okay, now coefficients of our polynomial are 9, -6, -44, 30, and -5. All right, bring down 9, multiply, add, multiply, add, multiply, add, multiply, and success. We get 0. Okay, now no other number in our list appears to be a possible rational zero. But at this point, we started with a fourth degree polynomial. The polynomial here in the quotient is 1 degree less than that. So it's third degree. We don't have any general methods of solving third degree polynomial equations. So we really need to find another zero. Well, here's the thing. Oops, I erased too much. Let me put that back in. Here's the thing. This 0 at 1/3, where the graph is just touching, is indicating that 1/3 has a multiplicity of 2. Because remember, if a 0 has even multiplicity, the graph will touch but not cross the x-axis at that point. If 1/3 has multiplicity 2, it means you can use it again, right here. And see, I'm not going back to the original polynomial, I'm using the third degree quotient. Because if I can do one more successful synthetic division, I'll have a quadratic, I'll have a second degree quotient. Watch what happens. Bring down 9, multiply, add, multiply, add, multiply, add. And you see it worked again. So the graph was indicating that 1/3 could be used twice as a 0, based on the fact that the graph touched but didn't cross the x-axis at that point. So you can take advantage of little things like that sometimes to help you break down the polynomial, get lesser degree factors, and then find the remaining solutions or zeros of the polynomial. Okay, so what do we have at this point? Basically, what we have is a factored form of x minus a third, x minus a third again, and then our quotient, our final quotient there is 9x squared plus 0x minus 45. Now, with that quadratic, if we set that equal to 0, we don't need the quadratic formula to solve such an equation because there's no x term. B is equal to 0. All that's really necessary here, there we go again. Trying again. All that's really necessary here is to isolate x squared. 9x squared equals 45. If we divide by 9, x squared equals, forgive me, sorry. Apologize for the technical problems I'm having here. I'm trying to solve this equation. I'm really trying hard. Divide both sides by 9. X squared equals 5. Take the square root of both sides. Again, you see we're getting irrational solutions here. This would correspond to plus or minus, I think we're dealing here with, if I recall, is it 2 point, excuse me, just to make sure, 2.2, yeah. Approximately 2.2. See, if you look at the x-intercepts there, the other two x-intercepts do appear to be at now this is still not working right. One moment. At 2.2 and negative 2.2. That's square root of 5 and negative square root of 5. And that's why those x-intercepts didn't correspond to any of the possible rational zeros we had listed because they actually were irrational zeros. Again, those are real numbers, but they're not rational numbers, so they don't appear in the list of possible rational zeros from the rational zeros theorem. So we have found all of the real zeros, and so the I guess in this case we say the solutions, since we're talking about solving an equation here, would be x equals 1/3, or just say 1/3, and x equals square root of 5, x equals negative square root of 5. So one rational zero with multiplicity 2 and two irrational zeros that are opposites of each other. If I can get my computer to cooperate with me, I want to show you one more thing here. Cultural enrichment, but I think it'll be useful to show this to you. We have a partially factored form here for our polynomial. Let me just show you another way to express this. See, we basically have x minus 1/3 squared. I'm going to factor the 9 out of the other factor. That leaves you with x squared minus 5. So what I'm going to do, I'm going to put the 9 in front, then x minus 1/3 squared, and then x squared minus 5 is x minus the square root of 5 times x plus the square root of 5. See, again, as you can see, please forgive my computer problems. I'm not sure exactly what's causing this, but part of it has to do with me I'm putting my hand on the screen. It is a tablet, and I'm probably hitting some things I shouldn't be hitting with my hand or with my stylus or something. So please forgive me. As I mentioned in an email before I started doing these videos, this is amateur hour, and sometimes things don't go quite as smoothly as I would like. So I hope it's not too much of a distraction. But for me to start over and do it again, it's so much trouble that I have to kind of live with these problems. I just wanted you to see that from getting all of the solutions of the equation, we can also factor the polynomial. And it's kind of interesting to see that such a complicated fourth degree polynomial equation can actually be factored. So if you know the zeros, then you know the factors. That's the factor theorem. I just wanted you to see that. That's not really part of this problem, but it is kind of a consequence of the fact that we were able to find all of the solutions of the equation. So to summarize, list the possible rational zeros, use synthetic division to find actual zeros, and use the graph to help you to identify actual rational zeros and to start the process of breaking the polynomial down to the point where you have a quadratic factor that you can solve as a quadratic equation.